Hello and welcome to mathandsciencepower.com. My name is Joe and I'll be your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, so we are working on volumes of solids by revolution. And here is a list of the problems I'm going to be doing in this video so that you can click here and skip ahead. So let's just get right down to it. Okay, number one. I'm looking for the region bounded by the curves y equals 2 minus 1/2 x, y equals 0, x equals 1, and x equals 2. So the first thing I'm going to do here is draw the graph. Okay, y equals 2 minus 1/2 x. That's a linear equation. The y-intercept is 2. The slope is negative 1/2. This line here is x equals 1. That's a vertical line at x equals 1. And x equals 2. That's a vertical line at 2. Okay, and then here the slope is negative 1/2, so down 1 and over 2. Okay, so I'm looking for this region revolved around the x-axis. Okay, and it's going to be a three-dimensional solid, something like that, and we're trying to find the volume. Okay, so I need to integrate here from 1 to 2 along the x-axis, and I know that because that's the axis of which we rotated around. So I'm always going to be integrating with respect to the axis that we're rotating around, usually. Okay, and the formula is the radius here is from 0 all the way up to this line, which is 2 minus 1/2 x. So the area of one of these disks is pi times the radius squared. And the radius is this. So the area is actually going to be pi 2 minus 1/2 x, all of that squared. So this is what I'm going to be integrating. It's the area of one of the disks. And with respect to x, and the lines x equals 1 and x equals 2 are my bounds. That's how far I'm going to start at 1 and I'm going to integrate all the way up to 2. Okay, so starting at 1 and going to 2. Now, this pi is a constant. It factors out front. And there's two ways I can integrate this. I can either FOIL this out and then integrate it as normal, or I can use a substitution. I'm going to use a substitution. I'm going to use 2 minus 1/2 x. Alright, so that du equals negative 1/2 dx, and I multiply both sides by negative 2, and I get negative 2 du equals dx. Okay, so now I'm going to be integrating, and my new limits are when I plug in 1 here, I get 3/2, and when I plug in 2, I get 1. Okay, and then this part is u squared, and dx is now negative 2 du. So the negative 2 can come out in front, and we're integrating now with respect to du, or to u. Okay, so now we're ready to go ahead and integrate. Okay, u to the third over 3. Add 1 to the exponent and divide by that new exponent. And we're evaluating from 3/2 to 1. And as you can see, the lower limit is greater than the upper limit. So that means that this when I evaluate this, it's going to come out to be negative. But it's already negative out here, so a negative and a negative becomes a positive. Okay, so let's Okay. I'm going to start back up here. Negative 2 pi. When I plug in 1 here, I get 1/3. Now I'm going to subtract and plug in the lower limit here, and I'll just go ahead and write it here. It's going to be 3/2 cubed all over 3. I plugged in 3/2 here. Okay, so negative 2 pi 1/3 minus 3/2. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. And 2 cubed is 8. 2, 4, 8. And all of that is divided by 3. Okay, so negative 2 pi 1/3 minus, I have a fraction and I'm dividing here, so I need to multiply by the reciprocal. The reciprocal of 3 is 1/3. Okay, 8 times 3 is 24, so I get 27 over 24. So I need a common denominator here, which will be 24. I need to multiply by 8. So 8 over 24 minus 27 over 24. And 8 minus 27 is 19. Negative 19. And 24 stays the same. Okay, so this 2 and this 24, they cancel here, and the 24 becomes 12. The negative and the negative becomes positive, so I get 19 pi over 12. So there is the answer to number 1, and sit back and we'll take a break for a moment, and we'll come back and we'll have 5 more problems to do. Welcome back to mathandsciencepower.com. My name is Joe and I'll be your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, let's move on to number 3. And we're looking for the area, or the volume I should say, created by revolving the area bounded by y equals the square root of x minus 1, y equals 0, x equals 5, and we're going to be rotating about the x axis. Okay, so I'm going to start with a graph. Okay, and y equals 0 is the x-axis, and x equals 5 is out here somewhere. Okay, now y equals the square root of x minus 1, well, that's going to be a sideways parabola, and the minus 1 means I have a horizontal shift in the positive direction. So I've got this parabola, crosses here at 5 somewhere. This is 1, this is 5. Okay, and we're going to be revolving this about the x-axis. So this is coming down here, and this is being revolved. Okay, so one of our typical washers is right here somewhere, and it has a radius. Okay, that radius is the value of this function, which is square root of x minus 1. Okay, and we're going to start our integration at the left here at 1, and we're going to end at 5. So we need to integrate from 1 to 5, and the area of this disk is, well, the area of a circle is pi r squared, and in our case r is this, the square root of x minus 1. And I need to square all of that, so the square cancels the square root, and the area is pi x minus 1. And so that is what we will be integrating, this function. And integrating with respect to x. So this looks like a fairly easy one. The pi is a constant, I can go ahead and factor that out. Oops, and I don't need my parentheses anymore, as I just wrote another one. And integrating with respect to x. Okay, so let's integrate. This becomes x squared over 2 minus x, evaluated from 1 to 5. Okay, so pi, plug in our upper limit, which is 5 squared is 25 over 2 minus 5. Now I need to subtract and plug in the lower limit, so 1 squared is 1, this will be 1/2, minus 1, okay, and let's see, I'm just going to go ahead and give them all a common denominator, which will be 2, and fix the parentheses in this negative issue here. So this is fine, 25 over 2, minus, I want this to be over 2, so I need to multiply by 2 over 2, that gives me 10 over 2. And now I'm going to be subtracting this number, which it's fine, it's already over 2, and subtracting a negative, which means I'll be adding, and 1 is 2 over 2. Okay, there we go. Now 25 minus 10 is 15, minus 1 is 14, and plus 2 is 16. 16 halves, and 16 divided by 2 is 8. I get 8 pi. And let's move right along to number 5, which says that we want to take the bounded region bounded by x equals 2 square roots of y, x equals 0, and y equals 9, and rotate that about the y-axis. Okay, so let's start with our graph. Okay, I know we're going to be revolving around the x-axis, or the y-axis, so that means we have to be integrating with respect to the y. X equals 2 square roots of y. Well, they already have this solved for x for us, and this is just a parabola with a stretch factor, so something like this. And x equals 0 is the y-axis, and y equals 9 is our upper limit here. 9. Okay, so this is 2 square roots of y. So we're revolving around the y-axis here, something like this, and something like that. And one of my typical washers will be here. And this washer has a radius, and that radius happens to be the value of this function, 2 square roots of y. So the area of the circle is pi r squared, and my radius is 2 square roots of y squared. So the area is pi times 2 squared is 4, and square root of y squared is y. So the area is 4 pi y. So we need to integrate, and we're going to go from 0 to 9, and integrating the area, the 4 pi factors out, and the y stays, and we're integrating with respect to y. So integrating, we get y squared over 2, evaluating from 0 to 9, and we get 4 pi, 9 squared is 81 over 2. The 0 doesn't matter here, this is just going to make it 0. And 4 divided by 2 is 2, and then 2 times 81 is 162, and then we still have the pi. So 162 pi. So let's just move right along to number 7. And number 7 is the first problem where we're going to have to use the method of washers instead of discs. and what that means is there's going to be a void in the solid. It's not going to be completely solid, there'll be a hollow space. So number 7 says we want the volume of the solid bounded by the region y equals x cubed and y equals x about the x-axis. Okay, so let's start with our graph. Y equals x cubed, well, that's sort of parabolic, and y equals x is this straight line. And you can see here, if I plug in 1 for x, 1 cubed is 1. And if I plug in 1 for x here, 1 is 1. So y equals 1 when x equals 1. This point is 1 comma 1. You could also set these equal to each other and see that it has to be 1 equals 1. Okay, so we're revolving around the x-axis. So I'm going to draw this mirror image down here. And we're revolving. And one of my typical washers in here will be this with a hollow space. You can see that this is like a like the bell of an instrument, like a brass instrument. It's hollow inside. So now we actually have 2 radiuses. We have this tall radius to the outside here, which happens to be the line y equals x. And we also have this shorter radius, the smaller inside hole here, which happens to be the function y equals x cubed. Okay, so the area of the washer is pi times the large radius, I'm going to call it radius 1 squared, minus the empty space in the middle here, which will be pi times the smaller inside radius, which I'll call radius 2 squared. And here the pi factors out of each one, so the pi comes out and I get r1 squared minus r2 squared. Okay, and so that's what we're going to be integrating. We're going to integrate, and we're integrating along the x here because that's where we're revolving around, and we're going to start at 0 and end at 1. Okay, 0 to 1, and I'm going to integrate this. Okay, well, I should have plugged in my numbers, huh? The pi factors out. Radius 1, the outside radius, is x. So that's just going to be x squared. The inside radius is x cubed, and when I square that, I'm going to get x to the 6th. Okay, x cubed, and I'm squaring it, gives me x to the 6th. And now I'm integrating with respect to x. Okay, so let's integrate. This becomes x cubed over 3 minus x to the 7th over 7, and evaluating from 0 to 1. So the 0 doesn't matter because when I plug in 0, it's going to make both of these 0. So all I have to do is plug in the 1. 1 cubed is 1 over 3 minus 1 to the 7th is 1 over 7. My common denominator here will be 21. So 721 minus 321. Okay, and 7 minus 3 is 4. 4 pi over 21. So let's take a brief break, and when we come back we will finish the last 2 problems that we have. Welcome back to mathandsciencepower.com. My name is Joe and I'll be your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, let's move right along with number 9 here. And this one is similar to 7 because it will also have to use the method of washers instead of disks. So the region bounded by y squared equals x and x equals 2y is being revolved about the y-axis, and we're looking for the volume of the solid that's generated by that action. So let's start with our graph here. Okay, and y squared equals x is a parabola, but this time defined as a function of of y, so it's going to be sideways. And x equals 2y is a linear function. If I divide both sides by 2, I get half of x equals y. So my y-intercept is 0, and my slope is 1/2. So it's kind of laid out flat like this. And here's my intersection point out here somewhere. I can find that point by setting these two equal to each other. Y squared equals 2y because they both equal x. If I divide both sides by y, the y's cancel, and this y cancels the square. I get y equals 2. So the y value here is 2. And I'm revolving about the y-axis. Something like that. Okay, and in here is one of my typical washers. Okay, and as you can see, this washer is going to have a hole cut out in it. So the area of this washer is equal to pi times the outside radius, which in this case is 2y squared, minus the inside radius squared. So here the inside radius is going to be y squared. So my inside radius y squared, and then I need to square that, and oh, not ready for that yet. Okay, so my area is pi, and 2y squared will be 4y squared, and y squared squared will be y to the 4th. Okay, so we are going to be integrating this function, and I'm going to start at 0, and I'm going to integrate up the y-axis to 2. So from 0 to 2, and the pi will factor out, and we'll be integrating 4y squared minus y to the 4th dy. Okay, so we get pi, this becomes 4y cubed over 3 minus this becomes y to the 5th over 5, and we're going to evaluate from 0 to 2, and the 0 doesn't matter, that'll make both of these 0, so I only care about the 2, and 2 cubed is 8, and 4 times 8 is 32, so 32 over 3 minus, and 2 to the 5th power, well, it would be 2, 4, 8, 16, 32. So 32 over 5. And my common denominator here is going to have to be 15. So I'll get pi, and I'll have to multiply by 5 here, so 5 times 2 is 10, 5 times 3 is 15, plus 1 is 16 over 3. And I'll have to multiply by 3 here, so 3 times 32 is 96 over 15, and this was supposed to be over 15. Okay, so pi, and 160 minus 96, I need 4 more to get to 100, and then 60, so 64 over 15, and that does not reduce, so I get 64 pi over 15. And let's finish up with number 11 here. So number 11 is an interesting problem. We're bounded by y equals x squared and x equals y squared, but this time we are going to revolve about the line y equals 1. So let's start with our graph. The line y equals 1 is going to be a horizontal line that crosses the y-axis at 1. So y equals x squared, that's an easy one, that's a parabola. and x equals y squared, that's a sideways parabola. So here is y equals x squared, and here is, I'm going to solve this for y. I'm going to take the square root of both sides, so I get that the square root of x equals y. Because that's this function here. This is y equals the square root of x. Okay, and then I'm revolving around this line. And here's one of my typical washers. Okay, now the line y equals 1, revolving around that obviously makes the problem different. The radius is no longer the value of the functions. Instead, the outside radius, here's the curve y equals x squared. This is the curve that defines this radius. Okay, it's going to be the entire value up to 1 here, so 1, and then minus the value of the function here, and that's only going to leave me with the part in between, the radius. So I'm taking 1 and I'm subtracting this part down here, and I'm left with what's in the middle. So radius 1, or the big radius, is 1 minus x squared. And likewise, radius 2 is 1 minus, and I'm just going to say x to the 1/2, right? I like a fractional exponent. So what we're going to do is we're integrating, and we're integrating along the x here. We're really integrating down here, but you can think of it here, really it's down here. That's how we, our functions are valued off the x-axis, but we're integrating from 0 to 1. These cross at 1. 1, 1. So 0 to 1, and the pi factors out as always. The big radius squared minus the small radius squared, and integrating with respect to x. So I get pi. What I'm going to do is I'm going to go ahead and FOIL these out. I think that would be the easiest way to do it. So when I FOIL this out, 1 times 1 is 1. This I get negative 2x squared, and then I square it and I get positive x to the 4th. And then I'm going to subtract. When I square this, I get 1 minus 2x to the 1/2 plus x to the 1. And I'm still integrating with respect to x. So now what I'm going to do is I'm going to get rid of these parentheses and this negative sign in the middle here. I'm going to distribute my negative and cancel things. So here I have a 1, and here I have a minus 1. So these cancel. And then what I'm going to do is I'm just going to put them in ascending order. I'm going to start with the smallest exponent here. So it's a negative negative. That makes it positive. 2x to the 1/2. And then I have x to the first here, so it's a minus a positive, that makes it a negative x. Then here I've used those, here I have negative 2x squared, and here I have positive x to the 4th, and integrating with respect to x. So now I can just go ahead and integrate. So I add 1 to the exponent, which makes it 3/2, and I multiply by the reciprocal, so 2 times 2 is 4 over 3. X squared over 2 minus 2x cubed over 3 plus x to the 5th over 5, and I'm evaluating from 0 to 1, and I don't need to worry about the 0 because every term has an x in it. And plugging in 1 is easy here because 1 to any power is just 1, so it just becomes the coefficients. It's 4/3 minus 1/2 minus 2/3 plus 1/5. And these are all prime numbers, 2, 3, and 5. So my least common multiple here for my common denominator is going to be 2 times 3 times 5, which is 30. So to get 30 here, I need to multiply by 10. So I need to multiply the top by 10, which is 40. I need to multiply by 15. I need to multiply by 10 again, And then here I need to multiply by 6. Okay, so 40 minus 15 is 25, minus 20 is 5, and then plus 6 is 11. So 11 over 30. And that doesn't reduce anymore, so the answer is 11 pi over 30. There you go. On behalf of mathandsciencepower.com, my name is Joe. Thanks for watching.